Greetings, Internet users. In our quest for truth, cosmology tells us that our universe has not always been the same. 13.8 billion years ago, it evolved from quantum fluctuations in the vacuum, starting from a microscopic size of high energy to the estimated 93 billion light-years in diameter that it is today. It continues to expand and evolve, which means it can also have an end. Everything we see, stars, galaxies, and planets, will one day disappear, possibly sooner than you imagine. The universe is not static. A little over a century ago, physicists assumed a stationary universe that neither expanded nor evolved because that state was most efficient for formulating their theories. Just as Darwin removed us from creationism, Edwin Hubble was instrumental in discovering that the universe is expanding and that the most distant galaxies are moving away from us. This led to a series of hypotheses about our origins. If everything is expanding, it is evident that in the past, everything was much closer together. However, the challenge lies in the fact that bringing all matter together can only result in a singularity, what we now call the Big Bang. It was not an explosion but an expansion of our spacetime from an extraordinary quantum phenomenon. Science is not clear on how the universe will end, although we have four probable hypotheses. One of them is gaining increasing strength and is also the most terrifying. Since its inception, the cosmos has been expanding, and despite fluctuations, it is doing so at an ever-increasing rate. The culprit is dark energy, which permeates all of spacetime and expands it, creating the optical illusion that galaxies are moving away from us when it is the space itself that contains them. What does all this mean? If dark energy continues at its current pace and everything expands faster and faster, there will come a time when there is no longer interaction among the elements of stars. Their dispersion will prevent the formation of new galaxies and stars. However, gravity is bringing together large groups of nearby galaxies, hindering their expansion. This is happening with our local group, our galaxy, Andromeda, and large galactic clusters. Gravity triumphs over the expansion of the universe. Therefore, the fate of the universe depends on how gravity and dark energy evolve. Currently, the most distant galaxies are moving away from us because their gravity is weaker and not enough to counteract the effect of dark energy, which causes everything to expand like a balloon. We also do not know the total amount of matter in the universe globally or how gravity will influence it. Furthermore, we do not know if dark energy will undergo changes in the future. But if everything continues as it is, the most probable destiny is a thermal death or the Big Freeze, where all matter dissipates throughout the cosmos and nothing can interact. Stars will eventually extinguish, and new formations will be impossible due to the lack of material. Everything will succumb to the second law of thermodynamics. When the end of time arrives, it will not be a grand explosion or a serene and slow death. The universe will simply come to an end, leaving only energy of quantum energy in the vacuum. This is the hypothesis we consider most plausible. Until now, the second hypothesis is that dark energy will continue to grow over time, causing the expansion to accelerate even more. In this scenario, it would surpass gravity even at short distances, causing stars to separate from galaxies. Eventually, it could even overpower the four fundamental forces of the universe. For example, if it surpasses the strong nuclear force, atoms, stars, and planets would be torn apart, disintegrating into a soup of subatomic particles. This is known as the Big Rip. When the universe tears apart, the forces that hold the cosmos together will be defeated in a final battle. Billions of years from now, the universe will end as if it never existed. The third hypothesis has sparked much imagination, suggesting that the density of the universe might be sufficient for its expansion to eventually halt. This is known as the Big Crunch, where all matter would come together again in a single point with such density that it would form a spacetime singularity. This idea stems from the concept of an oscillating universe proposed by Richard Tolman. According to this view, every Big Bang would always lead to a Big Crunch in a series of infinite oscillations. The created universe is but a parenthesis in the grand cosmic eternity. The fourth hypothesis is the most terrifying of the four and is gaining strength as our understanding of particle physics increases. Physicists believe that it is possible for the universe to end suddenly and without warning in a grand gulp, known as the Big Slurp. If we were to remove all matter and energy from the universe, a minimal amount would still remain. Currently, we inhabit a universe with a specific vacuum defined by the Higgs field. To understand what the Higgs field is, we must first acknowledge that the universe is filled with this field, which imparts mass to particles. In the vacuum, virtual particle-antiparticle pairs continuously appear and disappear. Only real particles interact with the Higgs field. When a particle moves in the vacuum, it is actually moving through the Higgs field, and its interaction with this field gives it mass. The Higgs boson is just an excitation of that field, which can only be produced in particle accelerators. The Higgs field has a value in the vacuum of 246 gigaelectronvolts. It stores energy, and since the beginning of the universe, its potential has been changing due to the high temperatures present during the Big Bang. As the temperature decreased, the Higgs field is currently in this region, which is our present vacuum and precisely the value we have given it. If we extrapolate the Higgs field, we see that it reaches a point where it fluctuates and reaches its minimum before rising again. This means that our vacuum is not a genuine vacuum, but rather another vacuum called the true vacuum. Physicists refer to this as vacuum decay. The electroweak vacuum, corresponding to the Higgs field, sustains the universe and provides it with stability, much like Atlas in mythology, who held the sky to prevent its collapse. If the Higgs field were to suddenly reach the state of minimum energy, it would be a global catastrophe. There would be a breaking of symmetry between the electromagnetic and weak forces, which would have consequences for the strong nuclear force and gravity. Particle masses would change, and physical constants would be different. Matter would decay, and its effect would spread throughout the universe. The universe would consume itself and collapse from the false vacuum point, extending its reach to affect everything. It would be akin to opening the hatch of a spacecraft in the vacuum of space. This implies that there are many types of vacua, and we only live in one of them. The end of the universe would be apocalyptic, similar to an ecological disaster, but on a cosmic scale. We would be absorbed by nothingness or, at least, a vacuum with lower energy than the current one. There is a possibility of this happening. The chances are not zero. The discovery of the Higgs boson was a great achievement for physics, but it also allowed us to precisely measure the nature of the vacuum and what may happen to us. Physicists are studying this hypothesis, also known as spacetime decay, and it is interesting to explore this phenomenon. The first thing that would occur is the appearance of bubbles of nothingness floating in spacetime, in other dimensions, like a hole in space that expands infinitely, devouring everything it encounters. This idea was originally proposed by theoretical physicist Edward Witten and has now been reconsidered. Why would a bubble of nothingness form? The answer lies in string theory. There are tiny entities of energy called strings in a vibrational state that represents quantum gravity. These strings would form all the particles we know. The strings would be compacted in more than 10 spatial dimensions, too small for us to see them. For mathematical reasons, bubbles of vacuum cannot form in a four-dimensional spacetime, as predicted by Einstein, but they can in a multidimensional space. Remember, it is certain that the intensity of the Higgs field has varied since the beginning and can do so again. The fact that we are currently in this point of the vacuum and that there are other vacua is why we call it a false vacuum. According to the quantum field theory, we live in a state of stability in a false vacuum that could immediately transform into a true vacuum through the tunneling effect due to the wave-like nature of particles. The Higgs field could destabilize without warning, violating the principles of classical mechanics, lowering its potential energy. This transition would occur in the form of a bubble at any point in space and would expand at the speed of light, causing our false vacuum to become a true vacuum, obliterating galaxies and planets. The physical constants would undergo a radical change due to the strong gravitational field. At the center of the bubble, a singularity would form, where all matter would be disintegrated and propagate throughout the universe. In the final apocalypse, it is a bubble of vacuum extending through the cosmos at the speed of light, sweeping away everything in its path. When the great void reaches us, it will disintegrate everything we know. The vacuum bubble will reach us quickly and silently, disintegrating our atoms without pain or suffering. We will never know that we ceased to exist. There is another possibility for this ultimate ending, according to the theory of many worlds. It could be the case that a bubble of false vacuum is surrounded by true vacuum. In this scenario, it would grow exponentially and separate from the original spacetime, becoming a baby universe. From inside the bubble, it would appear to have accelerated expansion, but from the outside, it would give the impression of a collapsing black hole, disconnected from the rest of the universe. For the reassurance of some, you should note that the creation of bubbles of true vacuum is highly unlikely, with a possibility of trillions to 1. However, given that the universe still has several gigayears of life ahead, it will eventually happen at some point. It would be tremendously unfortunate if it were to occur within our lifetime. It is surprising that when we look at the universe containing Earth, stars, galaxies, and everything in between, it appears empty. However, that vacuum is not completely empty, and it provides stability to everything around us. The false vacuum allows planets to form and governs the laws that allow their existence. We live in a stable universe sustained by a false vacuum that balances the four fundamental forces. The universe is truly a sea of free and clean energy that we do not fully harness. But contemplating an end to everything is disconcerting. Gone are the times of imagining a static and eternal universe. Yet, when ignorance
ignorance is bliss, wisdom becomes madness.
Just like stars that maintain stability for a while and then become unstable, collapsing into supernovae, the vacuum of the universe can destabilize and initiate a cosmic catastrophe.
Nothing we know can compare to it.
We are subject to the whims of the grand cosmic machinery, and the more we learn about it, the more it terrifies us. If you enjoyed this video, please like, subscribe, share on social media, and leave your comments.